Come on. There we go. All right, so we're going to get started. So again, we're still looking at regular polygons. So the formula, we're quiet and we're paying attention now, because if you did not understand yesterday, we are still going over the same process. So you need to pay attention so you understand how to do it. So the formula for area of a regular polygon is the apothem, or lowercase a, times the perimeter divided by 2. Okay, so in that formula, P represents the perimeter, and A represents the apothem. And just as a refresher, a regular polygon means all sides and angles congruent. Okay, so all your sides are congruent to each other, all your angles are congruent to each other. Okay, so again, we're looking at finding the area of these polygons. So number 4, okay, this is a pentagon. How do we find the central angle? Do you remember how to do that? 360 divided by how many sides? Okay, so we're dividing by 5. That is 72 degrees. Okay, and that is your angle between your two radii. Okay, now radius again goes from the center to an angle. Okay, so this side here of 10 inches, that is your radius. Okay, so that's R. The apothem, or lowercase a, is that segment perpendicular to the side from the center. Okay, so that one will be lowercase a. So that 72 degrees, again, is between your two radii here. So what we really need is this little angle of our right triangle between our radius and apothem. How do we find that angle? Do you remember? This whole thing right here is 72. How do I find this smaller one? Divide it by 2. Okay? So this angle right here, we'll take our central angle measure, 72, and divide it by 2. Okay, it is 36. So that angle measure is 36. Now yesterday, when we were trying to find different sides, okay, our apothem, trying to find our radius, stuff like that, we had special right triangles. 36 degrees is not one of our special right triangles. We cannot use special right triangle rules. Okay? However, since it is a right triangle, we can use SOHCAHTOA. Okay, so we can use SOHCAHTOA to find our missing side measures. So over here, we have to find all of these different lengths. Well, we're already given the radius. Okay, the radius is 10 inches. Okay, we still have to find the apothem and the perimeter. So I'm going to label this small segment here, RS, as X. So I still need to find lowercase a and X. Well, if I go from this angle of 36 degrees, I can use either sine, cosine, or tangent to solve for those missing side lengths. So just like yesterday, if you need to rewrite your right triangle somewhere else so it's a little bit bigger and it's easier to look at, you can do that. Okay? So I have my right triangle here. This angle is 36. This is the apothem. This one is the radius is 10. And this side is X. Okay? Now, in order to use SOHCAHTOA, again, it does have to be a right triangle, which it is. you have to go from the acute angle that you're given. Okay, not from the 90-degree angle, from the acute angle. So that would be this angle of 36 degrees. Okay, then I want to identify my sides. Okay, with this angle of 36, 10 is always your hypotenuse. That across from that 90-degree angle, that's always your hypotenuse. Okay, so that side of 10 is the hypotenuse. This side of x is across from that angle, so that is your opposite side. And then the side next to it, next to that angle, is the adjacent side. Okay, so I need to find the opposite and the adjacent sides. However, I can't have two variables when solving an equation. So I do need to use this side with hypotenuse of 10. I'm just going to solve for x first. Okay, so don't look at the a. I have opposite and hypotenuse. Which one of my three trig functions should I use? I should use sine. Okay, that's opposite and hypotenuse. So I would take the sine of the angle we went from, which was 36, set it equal to the opposite side, which is x, over the hypotenuse, which is 10. Okay, and we just want to solve for x then. So multiply by whatever is in your denominator. In this case, it's 10, so that it cancels out on the right. You're left with 10 times the sine of 36 is equal to x. Okay, and you can plug this into your calculator then. Okay, so just 10 times sine 36. What'd you get?
5.8. Well, we rounded it to 5.9.
That's what I got. Okay, so I did get 5.9 as that x value. So now that I have this x value here of 5.9, you can do two different things. You can either use SOHCAHTOA again, or since you have two sides of a right triangle, to find the third side, you can use the Pythagorean theorem. Okay, so if you don't want to use SOHCAHTOA again and try and figure out which trig ratio to use, we can just use the Pythagorean theorem. Okay, so for that, I would say a squared, which is this side, plus our other leg is 5.9, that's squared, is equal to 10 squared. Did it the opposite way on my note sheet. Okay, so 5.9 squared is 34.81. Subtract 34.81 from both sides. And take the square root of both sides. And I'm just going to round to 8.1 for A. Alright, so now re-looking back at our picture up here. Okay, A is the apitham. Okay, I found A, that's 8.1. So I would say this apitham is 8.1 inches. Now I also found what x was. X was 5.9. Okay, that's this length from R to S. Well, in order to find the perimeter, I need this entire length here. But if this piece is 5.9, this piece has to be 5.9. Okay, so I would just have to multiply that by 2. That is 11.8. Okay, so that entire side is 11.8. Now there are 5 sides total. So I just take the side measure, multiply by how many there are to get the perimeter is 59 inches. Okay, so now that I have everything I need to solve for the area, we just use our area formula that I wrote out above. So A times P divided by 2. Okay, so we have our area is equal to, our apitham is 8.1 times the perimeter is 59. And that is divided by 2. And I got 238.95. And that would be in inches squared.
Wait, what?
Okay, questions?
Yeah.
Okay, so that's an example using SOHCAHTOA. All right, next example. Okay, again, we have a pentagon. So again, first thing we want to do is find our central angle measure. To do that, we take 360, divide by how many sides there are. Again, since it's a pentagon, the central angle measure is going to be 72 degrees, just like our last example. Okay, meaning this angle right here is what? That little angle. 36. Okay, this time we're given this entire bottom length. So one of the outer sides of the pentagon is 10. So what does that mean this piece right here is? 5. Okay, now I want to locate the radius and the apitham. Which segment is the radius in this picture? The solid line. And then the apitham would be the dashed line. Okay, so again, if you need to redraw your triangle, make it a little bit larger so it's easier to see. Okay, for this one again, you need to use SOHCAHTOA. This is not a 30, 60, 90 right triangle. You cannot use those rules. So we're using SOHCAHTOA again. Okay, so this time let's find the radius first. Okay, so I'm going to go from my angle. If I look to this side, that's considered the opposite side, so it is a cross from that angle. Right there, Alyssa. Yeah. Okay, and then the side that I want you to find first is the radius, since that one's labeled first right here. So that side would be considered the hypotenuse. Okay, so if I have opposite and hypotenuse, which trig ratio should I use? Opposite, hypotenuse. Yes. Okay, so I would use sine for that one. Okay, and it would be sine of the angle that we're going from, so 36. Okay, that's equal to the opposite side, so 5. over the hypotenuse is r. Okay, what do I do next to solve for this? Multiply by r. Okay, it cancels here. So we have r times the sine of 36 is equal to 5. What should I do next when I'm solving for r? Divide by sine of 36. Okay, so our r value will be equal to 5 divided by the sine of 36. And you can plug that into your calculator. That's because your calculator is in radians and is not in degrees. Okay, so when you plug that into your calculator, your r value should be about 8.5. Okay, so our radius is 8.5 inches. Okay, next, since we found two sides of our right triangle, what can we use now? Pythagorean theorem to solve for a. Okay, so we have the hypotenuse in one of the legs. So we'll take 5 squared plus a squared is equal to our hypotenuse, which we just found. That's 8.5 squared. Okay, 5 squared is 25. 8.5 squared is 72.25. Subtract 25 from both sides. That's 47.25. Then take the square root of both sides. And I got a to be about 6.9. Okay, so our apothem would be 6.9 inches. Okay, next thing I need is the perimeter of the pentagon. How do I find the perimeter of this pentagon? Not the radius. The side length. So I have one side is 10 inches. So all 5 sides have to be 10 since it is a regular polygon. So multiply it by 5. The perimeter would be 50 inches. Okay, next I can find the area using our area formula. So we'll take our apothem times perimeter divided by 2. Apothem is 6.9. Perimeter is 50. Okay, and I got 172.5. And that would be in inches squared. Okay, so it's the same process. Okay, same process. You're just using SOHCAHTOA first instead of special right triangle rules like we did yesterday. Okay, questions on number 5? Okay, it's a lot to take in, but you take it one step at a time. That's why I have everything laid out for you in each problem. Find the central angle, then find the radius, find the apothem, find the perimeter, and then find the area. Okay, don't skip around. Find every single side with that right triangle inside the pentagon or polygon that you're given. All right, I'm going to do one more on the back here. Okay, one more. So we want to find the area of the shaded region. It is kind of hard to tell on your sheet, but your shaded region is just these little pieces right here. Okay, those are your shaded regions. So first thing when you get a problem like this is to make a plan in your head, but I'm going to have you write it out. Okay, so we're going to write out a plan for this. So if I'm just finding those little pieces of that shaded region, how do you think I could do that? Austin?
The area of the
circle, and then the area of the pentagon inside, area of the circle minus the area of the pentagon.
Yes. Okay, so we can take the area of the circle and subtract the pentagon from it. Okay? So I would say, find the area of the circle and subtract the area of the pentagon. Okay, so just so you have it written out so you know what process you have to take. Okay, so we can find the area of the circle. Okay, if I look at the circle as a whole, I have a radius of 10. And to find the area, and I'm going to label it area of circle with a small c there. Okay, so I have area of the circle. We take pi r squared, and we have the radius. Okay, the radius is 10, so we can just plug in 10 for r. So we have pi times 10 squared. Okay, so the area of the circle will be 314.16 centimeters squared. So now that we have the area of the circle, we can find the area of the pentagon doing the same process we did on the front. Okay, so first finding the measure of the central angle. So we take 360, divide by how many sides there are. Okay, there are 5. Again, it's 72 degrees. Okay, if I draw in the apothem, it's not drawn in for me. Apothem goes from the center to the side and is perpendicular. Okay, now the angle between the radius and the apothem is half the central angle. Okay, so again, this angle right here is 36 degrees. Okay, now we're already given the radius. Okay, the radius was 10 centimeters. It's already given to us. And again, since this one is set up a little bit funky, I am going to redraw the triangle. Okay, so the radius was 10, so that's your hypotenuse. This angle is 36. I drew in the apothem. And I do need to find out what this side length is, so I label it as x. Okay? So, since on my sheet here it says to find the apothem next, I'm going to solve for A. Okay? Since I'm given this angle of 36 degrees, we have to use SOHCAHTOA again. And I want you to find A. So how could I set that up? What sides do I have? Using SOHCAHTOA here, an angle 36. What sides would I have? What's this side? Hypotenuse. What's this side? Adjacent. If I have adjacent and hypotenuse, which trig function is that? From the front? No.
Oh, cosine.
Cosine. So I'm going to use cosine of the angle. So 36. That's equal to, the adjacent side is A, over the hypotenuse is 10. Okay, multiply both sides by 10. So we have 10 times the cosine of 36 is equal to A, and we can plug that into our calculator. I got 8.1. Okay, so the apitham is 8.1 centimeters. Okay, now we do need the perimeter of this pentagon. So that means I need this missing side length here I labeled as X. Okay? Shh. I need you guys to focus, please. I'm missing this side length. Okay, I labeled it as X. So I have 2 of my sides in this right triangle. Okay, so I can use the Pythagorean theorem to find that third side. Okay, so using the Pythagorean theorem, I'd have x squared plus this A value I just found is 8.1. So 8.1 squared is equal to our hypotenuse squared. So I have x squared plus 8.1 squared is 65.61. And 10 squared is 100. Subtract 65.61 for both sides. So you get 34.39. And take the square root of both sides. And our x value is 5.9. Okay? Now, 5.9 is not the entire side, right? It's only part of that right triangle. So I do need that entire side length. So you just multiply it by 2. You guys all wonder why you're confused when you're doing your homework. Because you don't listen to me when I'm talking. So I'm given just this side of this right triangle, so I need to multiply it by 2 to get the entire side length. Okay, that is 11.8. So then to find the perimeter of this pentagon, I would take 11.8, multiply by how many sides there are. It's 59 centimeters. So next I can find the area. Okay, so to find the area, we'll take the apitham, which is 8.1, times the perimeter is 59, and divide that by 2. Okay, it is 238.95 centimeters squared. Now again, remember at the beginning of this problem, I was trying to find the area of the shaded region. So now I have both areas right here. And my plan to find the area of the shaded region is up here. So now all I have to do is subtract the two areas to get just the shaded piece. Okay, so my final area or total area shaded would be 314.16 and subtract 238.95.